Explain propositional logic. Propositional logic deals with statements that are either true or false, but not both. A proposition is a declarative sentence that has a definite truth value. Simple propositions can be combined using logical connectives to form compound propositions. Propositional logic is used to analyze logical reasoning and mathematical arguments. Explain logical connectives. Logical connectives are symbols used to combine propositions. The main connectives are conjunction, disjunction, negation, implication, and biconditional. Conjunction is true only when both statements are true. Disjunction is true if at least one statement is true. Negation reverses the true value. Implication is false only when a true statement implies a false one. Biconditional is true when both statements have the same truth value. Explain truth table. A truth table is a table used to determine the truth value of compound proposition for all possible combination of truth values of its components. It systematically lists all possibilities and helps verify logical equivalence, topology, contradiction, and validity of arguments. Explain topology, contradiction, and contingency. A topology is a compound proposition that is always true for all truth values of its components. A contradiction is always false regardless of truth values. A contingency is a proposition that is sometimes true and sometimes false, depending on the truth values of its components. Explain logical equivalence. Two propositions are logically equivalent if they have the same truth values in all possible cases. Logical equivalence can be proven using truth tables or logical laws. Common equivalences include De Morgan's law, double negation law, and implication law. Explain laws of propositional logic. Logical laws are rules used to simplify logical expressions. Important laws include identity law, domination law, idempotent law, double negation law, commutative law, associative law, distributive law, and De Morgan's laws. These laws are useful in simplifying logical statements and proofs. Explain predicate logic. Predicate logic extends propositional logic by including variables and quantifiers. It deals with statements that involve objects and their properties. Predicate logic allows more detailed reasoning compared to propositional logic. It uses predicates, variables, and quantifiers to express logical statements. Explain quantifiers. Quantifiers specify the quantity of elements for which a predicate is true. The universal quantifier means for all, and the essential quantifier means the rest exists. Quantifiers are used to express mathematical statements formally and important in logical reasoning. Explain rules of inference. Rules of inference are logical rules used to derive valid conclusions from given premises. Important rules include modus ponens, modus tollens, hypothetical syllogism, and disjunctive syllogism. These rules help in constructing valid mathematical proofs. Explain valid arguments. An argument consists of premises and conclusion. An argument is valid if the conclusion logically follows from the premises. Validity can be tested using truth tables or rules of inference. Logical reasoning ensures that correct conclusions are derived from true premises.